Welcome folks. In this video we are going to look at some questions from section A of mathematics paper 2 for the 2021, and we are dealing with a paper that was written by the internal candidates. So let's look at question 1 A. So we can see that we have been given a question where we are supposed to simplify. So to simplify means to make it simple. Now, how can we simplify a problem like this one? So let's first look at the numerator. So the numerator is just a minus 12. There is nothing that we can do to the numerator. Now let's look at the denominator. The denominator can be factorized. Now we have a squared minus c. Now let's look at this 144. So what is the perfect square number for 144? Is just 12 squared. We know that 12 times 12 we get 144. Now here we are going to use difference of two squares method. So that's a method that we are supposed to use whenever you have each number or letter express the power 2. So the formula is like this. So we have a squared minus b squared. So what are we supposed to do? We open two pairs of brackets. Then the concept is you write a, another one here, plus, then the other one will have a minus, b here, also b here. So that is what we are going to do with our denominator of our question. So let's now factorize the denominator. So we'll do the same. We'll first begin by opening two pairs of brackets. Then we'll put our a here, the other one here. We'll put plus, minus, then 12, also 12 here. Now here I just want us we compare. So let's look at the above expression. So the above expression is a minus 12. Now with the two expressions below, we can see that there is one expression that is similar to the above. So we can cancel, we'll cancel this one, we'll cancel also this one. So the numerator now is just 1 because there is nothing remains. Then on the bottom we have a plus 12. So this is our final answer for the first question. Now let's go to question B. A box contains 3 black and 2 white marbles of the same size. A marble is taken out at random from the box and not replaced. A second marble is then drawn. Calculate the probability that both marbles are white as Roman number 1, then 2 of different colors. So now, even if the question is not asking us to draw a tree diagram, we are going to draw a tree diagram because a tree diagram will give us a picture of what is happening. So now we can see that we have only 2 outcomes. So there is black, and the total number of black marbles were 3. Then white were 2. So the total numbers of these is just 5. Now our tree diagram will consist of 2 branches. So we are going to have 2 branches, and we'll consider this as our first peak. Then even here we are going to have now our second peak. So consider this one as our second peak. Now let's go back to our question. So we'll begin with black. So this will be our black. So is here. Then we are going to have white. Here white, then we'll have black. Now let's look at what are we supposed to do with the first party. So the first party, we'll just look at how many marbles were black. So it's 3 over the total. We add 3 plus 2 will give us 5. Then white were 2 over the total 5. So it's always the total of that number. Then for the second pick, we can see there is a condition that and not replace. So whenever we are told that it was not replaced, we are going to assume the first one. Let's assume that the ball that was picked was black and without replacement. So if one ball was picked without replacement, this means that there are 2 white black balls over what is the total will also be 4. Since after you subtract 1, remember that even the total must reduce by 1. Then for white will also be 2 over 4. Now for the other branch, we would now assume that the ball that was picked was white without replacement. So this means that there is only 1 white remaining over 4. Even here we are going to have this will be 3 over 4. So I want you to see the pattern here. So the pattern is the first branch, we considered this one to be affected. Then the other one must just be the same. Then for the other branch, you need to change. You affect the other branch. Then the other one must just be the same as the original here. So with the tree diagram, we are okay. Now let's look at question 1. So for question 1, we just want the probability that both marbles were white. So let's look at the possible outcomes. So here we are going to have this B and this B, which is here is C, black, black. Then this B and this white. Here we are going to have black, white. Okay, then this white and this B. Here we have white, black. Then this W and this W. Here we are going to have white, white. So the probability that we want is where we have white, white. So let's look at this white, white. So here what we are going to do is we'll say probability of 2 white will be is equal to W times another W. So the first W is this one. The second W is this one. So we need to do the substitution. So this will be 2 divided by 5 multiplied by 1 over 4. So let's look at 2 times 1 is just 2. 4 times 5 will give us 20. Then we can see that we can still reduce. So 2 into 2 here is just 1 over 2 into 20 will give us 10. So the probability of picking 2 balls of the same color, which is white, is 1 over 10. Now let's look at for Roman number 2 is just of different colors. So we just want to get where there is different colors. So where there is different colors is BW plus WB. So say probability of different colors. So it is BW plus WB. Now let's look at the first BW. So the first letter indicates the original. So the original for B is this number 3 over 5. Then W is this number. So we are going to multiply 3 over 5 times 2 over 8. 3 over 5 times 2 over 4. plus c. Let's go back to WB. So WB is this number, 2 over 5 times 3 over 4. 2 over 5, 2 over 5 times 3 over 4. Okay, so 3 times 2 will give us 6 over 20, plus c here also it's 6 over 20. So no need of finding the lowest common denominator. We can just add the numerator 6 plus c. 6 will give us 12 over 20. So what number can go into 12 and 20 is 4. 4 into 12 will give us 3. 4 into 20 will give us 5. So our probability of finding two balls of different colors is 3 over 5. And also you can find this probability. You can find by you find first the probability of picking of two balls of the same color. So we have the first one is BB. So BB is 3 over 5 times 2 over 4. So let's try this. So different colors. So BB it's 3 over 5 times 2 over 4 plus C white it's 2 over 5 times 1 over 4. So it's 2 over 5 times 1 over 4. So here we have 6 over 20 plus 2 over 20. Then 6 plus 2 will give us 8 over 20. So what is the probability of this one? So 4 into 8 will give us 2 over 4 into 20 will give us 5. So this is the probability of picking the same. But how can we find now probability of picking different? So we can now say 1 minus 2 over 5. So that's a point here. So we know that our lowest common denominator is 5. 1 into 5 is 5 times 1 will give us 5 over 5 into 5 times 2 will give us 2. 5 minus 2 is 3 over 5. So we can see that we are still getting the same answer here. Then there is another one that if in terms of for those people that may find it difficult to simplify fractions, so I want to see how I can share with you guys. So the concept we know it's probability of different. Then we are saying it's 1 minus 2 over 5. So what are we supposed to do? Let me show you. So the focus is this is same as 1 over 1. So let's look at the denominator of the other fraction. So the denominator of the other fraction is just 5. So we are going to multiply 5 times the numerator of this, also 5 times this. So we know that 5 times 1 will give us 5 over 5 minus 2 over 5. So this will be 5 minus 2 is 3 over 5. So for those that may find it difficulty to deal with fractions, you can simplify your answer like this. Now we move on to question 2a. Now question 2a, we are taught to evaluate. Then we have this integral sign with the upper interval of positive 1 and the lower interval of negative 1. Then in the brackets we have 1 minus 4x plus 3x squared dx. So what are we supposed to do? We are going to integrate. That's what we are going to do. So let's look at that one. So we have 2a. Okay, so what are we supposed to do whenever we have been given intervals? So remember, Whenever you have been given intervals, these numbers here, remember that what you're dealing with is a definite integral, and definite integral is just actually the area under the curve. So what are we supposed to do? First, what I'm going to do is first I'm going to arrange this given function or equation, but I want to begin with the one with the squared. You can solve it like this if you know, that's okay, but I prefer beginning with the one with the highest power. So it's 3x squared minus 4x. So 4x here, whenever you're not given a power, remember that the power is same as 1. Then plus 1 over dx. So what are we supposed to do? What we are supposed to do is we are going to add 1 to the power, then divided by the same result. So this is 3x 2 plus 1, you do the same over 2 plus 1. Then we move on to the next one, 4x, this will be 1 plus 1 over 1 plus 1. Then what happens to this constant? This constant, you need to attach letter x to it, so this becomes 1x, which is just x. Then what are we evaluating? We are evaluating from -1 to +1. Now let's simplify the inside part. So we know that this will be 3 over 2 plus 1, 3 times x raised to the power 3 minus 4 over 2, which is 1 plus 1 is 2, raise times x raised to the power 2 plus x, then evaluating from -1 to +1. So we can see that there are some numbers that we can cancel inside. So we can cancel these 3, then this will give us x raised to the power 3 minus 2 here is 1, 2 here is 2. So have 2x squared plus x, then evaluating from -1 to +1. Then we can see that with integration we are done. So what are we supposed to do at this stage? We are going to write these two of these expressions that we have inside our bracket. So this will be x raised to the power 3 minus 2x squared plus x. This will be evaluated using 1. So the first one, you consider the upper number or the upper limit, then minus, you subtract the exact expression. But this time we are going to evaluate this one by using -1. So that's what you are supposed to do after you integrate. Then what are we supposed to do? This means that where there is x, we are going to put 1 here. So let's begin. 1 raised to the power 3 minus 2 times 1 raised to the power 2 plus 1 minus, then we'll do the same. So this will be -1 raised to the power 3 minus -2 squared plus -1. So let's see how we can evaluate these numbers. So 1 raised to the power 3 is just 1. Then here we are going to have 1 times 1 is 1 times 2, which is -2, plus this one here minus -1 raised to the power 3. This is same as -1 times -1 times -1. So -1 times -1 is +1 times -1, which is -1. So whenever a negative number is raised to the power 3, the sign does not change. Then here we are going to have -1 squared is +1 times -2, we get -2 minus 1. So here we can see that we can add 1 plus 1 will give us 2 minus 2. Then here we are going to add, so this will give us -4, since these numbers consist of the same sign. So here we'll see that this will give us a 0. Then negative times negative is 4. So our final answer is 4 units squared. So that's how we can evaluate a question like that one. Now Let's look at the question B. At a certain secondary school, all the learners in grade 12 take at least one of the following optional subjects. There is French, home economics, and geography. 20 learners take French only. 25 learners take home economics only, and 22 learners take geography only. Furthermore, 9 learners take French and geography. 12 learners take French and home economics. 15 learners take geography and home economics. And 4 learners take all the 3 subjects. Roman number 1, illustrate this information in a Venn diagram. So our first step is we are going to draw a rectangle. Now under this rectangle, we are going to put 3 circles because we are dealing with 3 sets. Now when writing these 3 sets, we are going to make sure that the 3 sets intersect at one point. There should be the intersection of all the 3 points. Why? We have been given the point that there was a certain number of learners that did all the 3. So let's look at the question. So the question is we are dealing with so there is French with F, home economics HE, geography G. So we know we are going to have French. Then here we are going to have home economics. Then here we are going to have geography. Now, after we were done, we can now look at what are we supposed to do. So first begin by indicating those that did all the 3 subjects. So 4 learners take all the 3 subjects. So we are going to indicate this. So 4 will be here. This is the intersection of all the 3 learners. Now after we are done with this one, we can go back to those that did 2. So from this we can see that 15 learners take geography and home economics. So 15 take geography and home economics. Now we can see that this 4 is part of those that did 3 at the same time, is part of those that did 2. So from that 15, we know that 15 did geography and home economics. So we are going to subtract 4. So 15 minus 4, we are getting our 11. So our 11 will be here. Now this 11 shows that these 11 did home economics and geography only. So that's the point here. Let's go back to the other one. So we have 12 learners take French and home economics. So 12 for French and home economics. So French. Now from that 12 we have 4. So 12 minus 4, we are going to have 8. So this means that 80 students take French and home economics only. Then let's go back to the other one. So the other one is 9 learners take French and geography. 9 take French and geography. Then from that 9 we have this 5 here. So we subtract 9 minus 4, we have 5. Now let's go back to the numbers on top. So the first number here, we have 20 learners take French only. Now whenever we have this only, please do not subtract the numbers that are in French. So that 20 will just be written like that. We are not going to do any subtraction because we know that there is this condition of only. Then 25 learners take home economics. See, there is also only here. We are not going to do the subtraction. So how many are there? 25. So you just have to write 25 like this. Then what else? 22 take geography only, so we put 22 here. Then do we have those that did not do anything? No. So the first question, Roman number 1. So B, Roman number 1, we are done. Now for A, Roman number 2A is how many grade 12 learners are at this school. So we just want to find the total. So how can we find the total? So say total learners, we are just going to add all the numbers. So it's 20 plus 80 plus 25 plus 5 plus 4 plus 11 plus 22. So 20 plus 8 plus 25 plus 5 plus 4 plus 11 plus 22. So according to my calculations here, I'm getting 95 learners altogether. So that's what we are supposed to do. Then for B, take home economics and geography, but not French. So we don't want anything that has to do with French. So let's look at the numbers. So 20 is part of French. We are not interested in that. Then 8 is also part of French. 4 is part of French. 5 is part of French. So the numbers that we are interested in are 25, 11, and 22. Now this question sometimes seems to be complicated, because for some they may think since we have take home economics and geography, so here the argument is it 11? Are we supposed to get 11, or we are supposed to add 22 plus 11 plus 25? So on this one, I want to hear also from you viewers, what do you think of, how do you answer this question? Let's share. Now according to me, since we are not told this term of only, then we are going to consider every member of home economics and geography, as long as that number is not coinciding in French. So to me, I think 25 plus 11 plus 22. So 22 plus 11 plus 25. So 22 plus 11 plus 25. So here we have 58 as our total. So now let's look at C. Take 2 optional subjects only. So where do we get the answers if you are given 2, then with this language of only? So where we get is where I'm crossing this. So this is where we have 2 only. So it's 8 plus 5 plus 11. So 80 plus 5 plus 11. So 8 plus 5 plus 11, I'm getting 24 as my answer here. Now let's move on to the next question. Now for the next question, we have question 3A, the second and the fifth terms of a geometric progression are 16 and 2 respectively. Find A, the common ratio, and first term. So let's see how we can summarize this question. So we have question 3A. So the first term we don't have. The second term we have it. So the second term is 16. Okay, so we have term 1, term number 2. Then third term we don't have, fourth term we don't have also, then fifth term we have it. Our fifth term will be 2. So this is our fifth term. Now how can we solve for common ratio and first term? So we are going to first begin by finding the common ratio. So we are going to form two equations. So let's solve the first equation. So we know that the formula for GP nth term is Tn is equal to A R n minus 1. So begin with second term. So whenever we deal with a second term, we know that Tn is equal to 2. Now where there is Tn, we are going to put our second term. So what's our second term? Our second term is 16 is equal to A R, then n, what's our n? 2 minus 1. So we have 16 is equal to A R, 2 minus 1 is 1. So we'll say this is our equation 1. Now let's look at the equation number 2. So equation number 2, Tn is equal to A R to the power n minus 1. This time equation number 2 will be formed by the fifth term. So our n is equal to 5. So here we are going to put 2 is equal to A R 5 minus 1. So 2 is equal to A R 5 minus 1 will give us 4. Then we have equation number 2. Now after we are done with finding the second equation, what are we supposed to do? Now let's look at the equation 2. So equation 2, we can see that we have a 2 here. Then here we have a 16. So what are we going to do? So what we are going to do is, I want us to we break this 16 so that we are able to get 2. So 16 is same as 8 times 2, which is equal to AR. This is the same. So that we know that here 2 is equal to this. So where there is 2 on this one, we are going to substitute with this. So we'll say 8 open brackets. So we have AR raised to the power 4, then is equal to AR. Then upon reaching here, what are we going to do? So what we are going to do is, here we are going to divide by, first let's divide by R, also here by R. So we know that we can cancel R here. We have 8 R to the power 3. R to the power 3. Where is 1 R? That 1 R has been cancelled. Also here we can cancel. We have A. So let's also get rid of A. We divide by A. Also here by A. So 8 R raised to the power 3 is equal to this into this will cancel, will give us 1. We can divide by 8. Also here by 8. So R to the power 3 is equal to 1 over 8. Since we are not solving for R cubed, we are solving for common ratio, which is a single R. So we are going to introduce the cube root here, also the cube root here. So that if you cancel, we have R is equal to, what is the cube root of 1 is just 1. What is the cube root of 80 is 2. So our common ratio is 1 over 2, or in decimal point this will be 0.5. So we have our common ratio. Now, okay, let's say we don't want to use this principle. How can we solve for common ratio? So let's do this. Now, if you are trying to solve for the same common ratio, what we are going to do is, from these numbers, I will start from 16. So instead of 16 being on the second position, let's just assume 16 is on position number 1. Then here we have position number 2. Here we have position number 3. Here we have position number 4. So what are we saying? Let's say we have 16 becomes our first term. Then 2 become as our last term. So how can we find the answer? So whenever you are trying to use this concept, make sure the two numbers that you have, one must be the first one, the other one must be the last one. Now let us write the formula for the nth term. So it's Tn is equal to AR n minus 1. Remember, the n is equal to 4 this time. So where there is Tn, you put the last term. So the last term is 2. Is equal, what's our A? Our A is 16. So we put 16 here. Then R times the power 4 minus 1. So we have 2 is equal to, here 16, we are going to have 16 times R, 4 minus 1 will get us a 3 over 16 over 16. So that if we cancel, we can see that we are going to have R raised to the power 3 is equal to 2 into 2 is 1 over 2 into 16 will give us 8. If we take the cube root, we are going to see that our R will be 1 over 2 or 0.5. So we can see that we still have the same answer. Now the other question is, we found the common ratio. Now we want to find the first term. So let's look at the sequence. So the sequence is dash 16. So 16 up to 2, we can see that this sequence was multiplied by half. So if you say 16 times, so you say 16 times 0.5 because it's our common ratio. So here we are going to have 8. Then the same 80 times 0.5, you get 4 here. Then 4 times 0.5, you get 2 as this 2. Then how can we find the number backward if forward is done by multiplication? So instead of multiplying, we are going to divide. So you say 16 divided by 0.5. So you get the first term is 32. And it's making sense. We can see the pattern here. Then for Roman number 2, we want the 12th term. So the sum of the 12th terms. So the formula is sum is equal to, so we can see that our common ratio is less than 1, so this will be 1 minus R to the raised to the power n over 1 minus R, since our common ratio is less than 1. So let's do substitution. So sum of how many? 12 terms. What is our A from the sequence? Our A is the first number is 32. So we put 32, 1 minus 0.5 raised to the power 12 over 1 minus 0.5. Okay, so 32 is equal to what is 0.5 raised to the power 12. So according to my calculations, I'm getting 2.44140.625 times 10 to the power negative 4 over 1 minus 0.5 will give us 0.5. So this number, let's say minus 1 minus that number will give us 0.999755859 over 0.5. Then this number times 32, so I'm getting 31.9921875 over 0.5. So divided by 0.5, so I'm getting 63.98 as our sum. So that is our answer. Okay, sorry, I've missed the question. Yeah, I thought it's a sum. Now it's a 12th term. Okay, let me redo. So for 12th term, it's Tn is equal to a n minus 1. So 12th term, we want the number on position number 12. Our first number is 32. Common ratio is 0.5. Then we have 12 minus 1. So we have 32. Then 0.5. Here we have 11. Do not multiply 32 times 0.5 for now. First, we need to make sure that we simplify it according to the power. So 0.5 raised to the power 11. So this is 4.8828125 times 10 to the power negative 4. Then the same number times 32. So I'm getting 0.01565. So if we want to write it as is in standard form, so we can see 1, 2. So this is same as 1.5625 times 10 to the power negative 2. So this is our answer on position number 12. Then for Roman number 3, what we just have to do is, instead of using 12, we just change 10 here. The rest is correct. So we're just going to cancel this number. So what is the 0.5 raised to the power 10? So I'm getting 9.7665625 times 10 to the power negative 4. So I'll cancel these. Then subtract a1. So it's give me 0.999023437 over 0.5. Then times 32. So getting 31.968 over 0.5 divided by 0.5. I'm getting almost the same answer. How possible is this? So I'm getting 63.9. How possible is this point here? Okay. So that's what you can do. That's how to find the answers for the sum. Okay, so now let's move on to question 4a. Solve the equation 2x squared minus 13 plus 14 is equal to. 0, giving your answers correct to 2 decimal places. So 4a is given 2x squared minus 13x plus 14 is equal to 0. So the point is y is equal to ax squared plus bx plus c. So this is a quadratic equation. So the coefficient of x squared is a, which is 2. Then the coefficient of x raised to the power 1 is b, negative 13. Then our c is 14. So we are supposed to write our formula. So x is equal to minus b plus or minus the root of b squared minus 4ac divided by 2a. So let's do substitution. So what is the value of b? Negative 13 plus or minus, here it's negative 13 squared minus 4. What's our a? Is 2. Our c is 14 divided by 2 times 2. So here we know that negative times negative is positive. 13 plus or minus 13 squared is 169. Then 4 times 2 times 14. I'm getting 112 over 4. So we now subtract 169 minus 112. So I'm getting 57. Then we need to find the square root of this number. So 13 plus or minus, what is the square root of 57? So I'm getting 7.549834435 over 4. Then what do? You separate. So 13 plus this number 7.549834435 over 4, or the other value will be x is equal to 13 minus this number. Over the same number here. So 13 plus 7.5489344. So this is giving me 20.5498344 over 4. So I'm getting 5.13745. So this will be 5.14. Then you will have 13 minus 7.549 834 435. So I'm getting 5.450165565 over 4. So I'm getting 1.36254. So the final value is 1.36. So that's what I'm getting according to my calculator. Then we move on to question B. In the diagram below, vector OA is equal to 4A, OB is equal to 3B. M is the midpoint of AB, and OB is equal to 3BD. So express in terms of A and OB, vector AB. So if we want to find a vector AB, we'll say AO. So we have AO plus C or B. Okay. Now remember, OA is 4A. So if we move from A to O, we are moving against the arrow. So introduce the negative. So this will be vector 4A. Then OB, we just get it the way it is vector 3B. So we have 3B, which is, we begin with the one with the positive. So 3B minus 4A. So this is our vector. Then OM. So OM, for us to move from OM, so we need to draw a line since it was not given. So for us to move from OM, we'll move from OA plus AM. So we'll say OA plus AM. Now OA we have is vector 4A plus C. Now AM, we know that M is the midpoint of AB. So this means that we just want half of AB. So this will be half of vector AB. So what do you do here? We can now say 4A, then plus C, half 3B minus C, 4A. So 4A, now we can expand 1 over 2 times 3B. This will be 3 over 2 vector B minus 1 over 2 times 4A. This will be 2A. This is like this. So 2 here is 1, 2 here is 2. That's where we are getting. So we can correct the like terms. So 4A minus 2A. This will give us 2A plus 3 over 2 vector B. Then AD, we want to find AD. So there are so many ways. So for us to move from A to D, since the vector AB we have it, so we'll say AB plus BD. So AD is equal to AB, vector AB plus BD. What is the vector AB? We have it, this one here, 3B minus 4A. Now we need to find the BD. So how can we find BD? Let's look at this one here. So let's look at this one. So OB is equal to 3BD. So this means that there are 3 segments of BD that are making OB. Or we know that the concept is OB is equal to 3BD. So let's put the vector for OB. So what is the vector for OB? OB is 3B is equal to 3BD. Now let's make 3BD the subject formula. So we divide by 3, also we divide by 3. So what's our BD? So 3 into 3 is 1, so the BD is just the vector B. So this means that there is B here. So plus B. So 3B plus B minus 4A. 3B plus B will give us 4B minus 4A. MD, so the Roman number 4 is MD. MD. So want to move from M up to D. So what are we supposed to do? So say MB, we move from M to B plus B to D. We know that M is the midpoint of AB, is half of AB, so it's half of 3B plus 4A. BD, we have it, is vector B. Then here we are going to say 1 over 2 times 3B will give us 3 over 2B plus B, we'll say over 1, minus 1 over 2 times 4A will give us A. So we can find the lowest common denominator, or what we can do, we can just do the same. So the way I did is, it's this same as 1 over 1, like this. So multiply these two. 2 times 1 would also do to the denominator. So 2 times B will be 2B over 2. So that 3B plus 2B will give us 5B over 2 minus 2A. So that's our answer here. Now we move on to question 5. Given that matrix P is equal to this, so 5A matrix P has the elements 1, 2, 2, negative x. Find the value of x for which the determinant of P, so determinant of P is equal to negative 3. So we know that these are major diagonal elements. Then you have the minor here. So what are we supposed to do? We are going to multiply elements from the major diagonal, which is 1 times negative x. Then we subtract the product of minor diagonal. So the determinant is given is negative 3. 1 times negative x is negative x minus 2 times 2 will give us 4. We can now collect the like terms. So negative 3 plus 4 is equal to negative x. So here we have 1 is equal to negative x over negative. So x is equal to negative 1. So x is equal to negative 1. So let's look at our original matrix. So original matrix will have 1, 1, 2, 2. Then x is negative 1, so which is here we're going to have positive 1. The reason why we have positive 1 because there is a negative here. So negative times this negative, our answer is positive 1. So now for Roman number 2, hence find the inverse of P. So the inverse is 1 over determinant multiplied by the adjoint of matrix P. 1 over determinant is negative 3. So let's find the adjoint. So the adjoint of matrix P, what you do to the major diagonal, you interchange the position. So 1 will come here, 1 is, so since we have the same number, we just write them. Then for minor diagonal, you interchange the sign. So positive 2 becomes negative 2, even here becomes negative 2. So this will be 1, negative 2, negative 2, 1. So this is our final answer. Then for this one, start the flowchart. Then we can see we'll have start, enter x. So the question is, what is the question? Write a pseudocode corresponding to the flowchart. Okay, so we'll say start this one. Then what are we supposed to do? We enter x. Then look at this, is x less than 0. But whenever you are writing a pseudocode, this should be written as if if x less than 0. Then what are we supposed to do? There is yes. So we'll say if then, so then simply means yes. Then what are we supposed to do? Print error, x must be positive. Then or else simply means if no. This one, what are we supposed to do? Calculate r is equal to capital letter R times cos x. Then you say and if display R, then what are you supposed to do? You stop. So this is our pseudocode. So that is our answer for this. So that is what we are going to do, and this is where we are going to end with this question. So that's it for this video. Thanks for watching.